Okay, so we're going to get pretty familiar with the trig for the next little while. Like I said, the next 3 units. And how it's going to break down is this unit is all about how to evaluate trig expressions as well as solve trig equations, some of which you guys have done in grade 11. Okay, you remember we did some trig expressions using the unit circle, and then we solved some trig equations using the unit circle as well as a calculator. We're going to do more complex equations, and we're also going to talk about a new unit of measure for angles called radians. So that's going to be sort of the new part of this first unit on trig. The second unit on trig, we're going to deal with, just like we were doing in the first 3 units, graphing trig functions. Okay, we can graph them. If we're given the graph, we can find the equations of them, and we can solve problems using them as well. And then the third unit on trig is going to be taking trig expressions and proving that they're equal to each other, finding equivalent trig expressions. So that's sort of the simple way of breaking it down. Before we get into evaluating trig expressions and solving trig equations, which is going to be towards the end of this unit, we need to know some preliminary stuff, okay? Because we want to be able to evaluate trig expressions for any angle. In grade 10, you guys did like 0 to 90 degrees. You solved trig equations. Last year, you did 0 to 360 degrees. You evaluated trig expressions and solved trig equations. This year, we're going to go below 0 and past 360. So you'll be able to do any angle. But before we do that, in order to evaluate and solve these things, we use a coordinate grid to help us draw angles, which will help us do the trig on these angles. Okay? And this is actually straight from last year. So when we draw an angle on a coordinate grid, an angle obviously is made up of 2 arms. The first arm, which usually is horizontal, and then the second arm, which is somewhere, going to get my thing right, counterclockwise to the first arm, and then we measure from the initial to the second arm. Well, on a coordinate grid, the initial arm is always going to be the positive x-axis. Okay. And then depending on the measure of the angle, the second arm, which we call the terminal arm, where the angle ends, is going to be somewhere in the 4 quadrants. We'll focus on the first quadrant to start with. So this is the initial arm. This is the terminal. And this is the angle that we measure. And usually you guys are used to measuring counterclockwise, starting from the initial, going to the terminal, which we do with most angles, except we're going to introduce negative angles, which actually go the opposite way. Okay? Anyway, the angle between these 2 arms, we usually refer to as theta. I mean, it can be called X, it can be called Y, it can be called other Greek letters. Okay, but theta is the most common. And then finally, and this is something that you learned way back, where the 2 arms come out from, where they meet and come out from, that's our vertex of the angle. It's always going to be the origin. So this is how you would draw an angle in quadrant 1. Which means you are drawing angles. Theta is between 0 degrees and 90 degrees. 0 and 90 themselves are special angles that we'll talk about a little later, but all the angles between them, they would all appear in quadrant 1 if we used a coordinate grid to draw them. And now we'll just do the other 3 quadrants. So in quadrant 2, well, our initial arm always faces the positive x-axis. Our terminal arm is going to end somewhere in quadrant 2. And then our angle is going to look like that. Well, all the angles that end in quadrant 2 are going to be obtuse angles. In other words, between 90 and 180. So theta is between 90 degrees and 180 degrees. And like I said, we do the same thing for quadrants 3 and 4, but they represent different spans of angles. So in quadrant 3, initial arm, terminal arm is going to end somewhere in quadrant 3. And there's our angle. And any angle that ends in quadrant 3 will be between what? 180 and 270. So theta is between 180 degrees and 270 degrees. And then finally, quadrant 4. Initial arm stays the same, but our terminal arm is going to be somewhere in quadrant 4, and our angle is going to be that. Which means any angle we draw in quadrant 4 is going to be between 270 degrees and 360 degrees, which is a complete circle. Okay. So that's the first part, is drawing these angles using a coordinate grid. Second part is when we actually do the trig, when we actually evaluate trig expressions. So if I said, find the sine of 150 degrees, or if I gave you an equation, I said the cosine of some angle theta is 240 degrees, find what theta could possibly be. Well, in order to do that, we use what are called reference or related angles. Because when you guys first learned trig in grade 10, all the angles we used were between 0 and 90 degrees. And a reference angle for any other angle is always between 0 degrees and 90 degrees. Every angle on a coordinate grid has a reference angle, an acute angle, between 0 and 90. You just have to make sure you find it correctly. Okay? And how do you find the reference angle? Well, the angle is always going to be the initial arm is always going to be the nearest x-axis. And then the terminal arm is going to be the same as the terminal arm of the angle we're trying to find the reference angle for. This will make more sense. So in quadrant 1, let's draw an angle in quadrant 1. Its reference angle will be the angle between the terminal arm of this one and the nearest x-axis. So its reference angle is going to share the same terminal arm and the nearest x-axis, either positive or negative, which one's closer? This one? Yeah, the positive one. So in quadrant 1, every angle's reference angle is the same as its original angle. So if I said find the reference angle for 50 degrees, it's 50. It's the same thing. So the reference angle is always going to be equal to the original angle we're given. Or the other way around, if we're given the reference angle and asked to find the original, they're the same. Sorry, I should have added the nearest x-axis here. So they're always the same in quadrant 1. In the other quadrants, they're different. So let's draw a reference, or sorry, let's draw an angle that ends in quadrant 2. Like so. How do I find the reference angle? Well, one of the arms is the terminal arm of the original. And then the other arm, which turns out to be the initial arm, is the nearest x-axis, which is where? Left side or right side? Left side. So this is our reference angle. What do you notice about the relationship between the two? Yeah, they add up to 180, right? So if you're given one, you find the other by doing 180 minus. So if I want to find the reference angle, if I'm given the actual angle, like say 130, what? Stop it. There. Right. I don't know why it does it. It's so sensitive. Okay. All right. Find the reference angle if I'm given the original one. To 180 degrees minus the original angle. If I'm given the reference angle and told that it's in quadrant 2, I find the original angle by doing 180 minus the reference angle. In quadrant 3. Draw an angle that ends in quadrant 3 or terminates in quadrant 3. So like this. So the reference angle of any angle in quadrant 3, same terminal arm, and the nearest x-axis, which would be this one. So notice that in quadrant 3, the reference angle is always part of the angle that terminates in quadrant 3. In quadrant 2, they're separate, but they both add up to 180. But in this one, theta r is part of theta. The question is how much? So if I'm asked to find the reference angle, so if I'm given the original angle, so let's find it, say an angle between 180 and 270, 200. So let's say this is 200. How would I find this? Take the theta and minus 180, right? So subtract this portion away and you'll be left with the reference angle. So take the theta and minus 180 degrees. If I'm asked to go the other way, if I'm given the reference angle and told that it's in quadrant 3, how would I do this? I would have to take the reference angle and then add 180 to get the entire angle theta. So it'd be the reference angle plus 180 degrees. Quadrant 3 is a little tricky. It's not the same operation to find the reference angle or the original angle theta. And finally, in quadrant 4. So let's draw an original angle theta in quadrant 4. And then use the graph to find the reference angle, which hopefully you will see is the terminal arm, and the nearest x-axis, which is the positive one. So if theta ends in quadrant 4, theta r kind of completes the circle, right? So the relationship between theta and theta r, if theta's in quadrant 4, is they add up to 360. So if we want to find the reference angle, we're going to have to do 360 degrees minus theta, the original angle. If we're given the reference angle and told that it ends in quadrant 4, and we're asked to find the original one, it's going to be 360 minus whatever the reference angle you're given is. So reference angles are important when we evaluate trig functions or trig expressions and when we solve trig equations. Another piece of information that we need to know is how do the trig functions, the three basic ones, because we talked about the three basic ones, how do they behave in each quadrant? In other words, I'm talking about whether they're positive or negative. Okay? But if you did, and you can verify all of these with your calculator, if you did the sine of any angle between 0 and 90, the answer is always going to be positive. Same with cosine, same with tan. Okay? However, if you take the sine of an angle in quadrant 2 and cosine and tan, the sine is going to stay positive, but the cosine and tan are actually going to be negative. Okay? Where do those come from? How do we get those signs? Well, let's look at each quadrant. What I want to do is I want to form, because we know how to do trig using right triangles. So here I have an angle in quadrant 1. To make a right triangle, all I do is I draw a vertical segment from the terminal arm to the initial arm. Well, you could put arrows, they could continue, but I need a triangle to actually do the trig ratios. Because if you remember, we always use right triangles to do the trig ratios. And we use SOHCAHTOA. Because each side of the right triangle had a name depending on where the angle, acute angle we're talking about is. So in quadrant 1, this is really just grade 10. Okay, if this is the angle I'm talking about, the longest side, the slanted side that comes out from the vertex will be the hypotenuse. The vertical side will be the opposite side to the right angle, which means that this side will be the adjacent side. Okay. And I'm going to call these other names. So we're going to call this side x, because it makes sense. It's the length of x. Vertical is y. So we're going to call this side y. Remember what we called the hypotenuse? R. Excellent. We called it R, and the reason for that is when we talk about the unit circle. Because we make a circle that we put the right triangles in, which means that the segment that comes out from the middle to the circle is a radius. So that's what it stands for. So we're going to use those ones instead of adjacent, opposite, and hypotenuse. So in the first quadrant, the sine is going to be opposite over hypotenuse. The cosine is going to be, wow, what letter over what letter? X over. And the tangent will be y over x. Y over x. Notice everything's positive. Because we're going to the right on the x-axis, that's positive. Because we're going up on the y-axis, that's positive. And we always find the hypotenuse by Pythagoras, which means it has to be positive. So x is greater than 0 and y is greater than 0, which means sine is going to be positive over positive, which will give us a positive answer. So will cosine. So will tan. And like I said, we can confirm that with the calculator. Take the sine, cos, or tan of any angle between 0 and 90, it's always going to be positive. Okay. Quadrant 2. So let's draw an angle that ends in quadrant 2. Like so, and you can put arrows on the end if you want. But I need to create a right triangle. Well, obviously you can't connect the end of the terminal arm on that because that's not a right angle, or that's not a right triangle. What we have to do is go to the end of the terminal arm and draw a vertical axis down. So we're actually using a reference triangle. And notice the sides change a little bit. R is still going to be positive. Hypotenuse is still going to be positive. But notice I'm going to the left on the x. So it's actually negative x. But I'm still going up on the y, which means it's positive y. So the sine of any angle in quadrant 2 between 90 and 180 is still going to be positive y with positive r. Positive over and positive equals. This one is going to be adjacent negative x over positive r, which means it's going to be a negative over a positive, which is going to give us a negative answer. And again, you could confirm that on the calculator. Take the cosine of any angle, negative angle, or sorry, any angle between 90 and 180, the answer will always be negative. And tangent will be y over negative x. It's also going to have a negative answer because it's going to be a positive divide a negative, which is going to give us a negative. And then you see we continue the pattern in quadrants 3 and 4. So in quadrant 3, here's an angle in quadrant 3. But I need a right triangle to do the trig, so I got to go to the end of the terminal arm. And I always have to draw a vertical to get y. Remember, y is always vertical. Don't make your right triangle like that. Okay? Because The vertical has to be here. Never make a right triangle using the y-axis. Always one of the legs has to be the x. And here, well, we're going to the left on the x, that's still negative x, it's quadrant 2. Now we're going down on y, which means it's negative y. But if I did this squared plus this squared to find the square root, that's going to give me a positive answer. So that means the sine is going to be a negative value over the hypotenuse, or r, which is a negative over a positive, which gives me a negative answer. The cosine is going to be negative x over r, which again is going to give me a negative divided by a positive, which gives me a negative. But the tangent is going to be negative y over negative x, which is a negative divided negative, which means it's positive. And again, you can confirm that. Take any angle between 180 and 270, find the tan, it's always going to be positive. And this is why, because this is how we use the coordinate grid to set it up. And finally, quadrant 4. So we've got our initial arm, our terminal arm. There's the angle, but we're going to use a reference triangle that looks like this, which means that the x value, because we're on the right side again, it becomes positive. The y value is still going down, so it's negative, and r always positive. So the sine is going to be negative y over r, which gives us a negative over a positive, which is negative. The cosine is x over r, which is a positive divided a positive, which is the positive answer. And the tan is going to be negative y over x, which means a negative divided a positive, which gives us a negative answer. And so, what does that mean? That means, like, if you found a tan of, say, 60 degrees, it's going to be positive, okay? But if you find the related angle in quadrant 3, which would be 240 degrees, and you took that tan, it'd be the exact same answer. So with some of these, you're going to be able to take sine, cos, tan of more than one angle and get the same answer, which means that when we solve trig equations, we could get more than one answer. How do we remember all these signs? Oh, do you remember? Remember the phrase? All snakes talk crap. Start in quadrant 1 and go counterclockwise. All suckers hate chemistry. Okay? However you want to remember it. Why do we use these letters? Because this tells us the signs of the angles. All three trig functions are positive. Any angle between 0 and 90. Only sine is positive if we take the trig functions between 90 and 180. Only tan is positive when we take the trig functions between 180 and 270. And only cosine is positive when we take the trig functions between 270 and 360. That's how we remember those. Okay. So ASTC, you can make up whatever you like. Okay. So that's kind of some prep work that we're going to need to get us to the ultimate goal, which is evaluating trig expressions and solving trig equations. But right now, given what we did today, if I said this, I asked, tell me what that is without using a calculator. Okay. Well, obviously, if we use a calculator, we'll be able to get the answer and we'll know whether it's positive or negative. Okay. But from what we did today, the only thing we know right now is this going to be positive or negative? It's going to be negative. Okay. There's some other stuff we need to learn to actually find what the number is that goes after the negative. And we did that last year, and we'll review that this year. But then we're also going to do a different type of angle measure, which we're going to start the next class.